Hi everyone, welcome to the verification lab. So in this video, I'll be explaining ASIC verification flow. So in this entire session, I'll be explaining like how the real-time verification flow and one test bench architecture and how the real-time project workflow, like how to execute the test case, how to run the test case, and one project template I am already having. So in that I'll be explaining all these things, how the regression flow looks, how the regression report and how the coverage report looks. Everything I'll be explaining in this video. So let's start. So welcome to the world of ASIC verification. So first, let's understand three things about the verification domain. The first thing is what is verification and why chips need it, and how do we verify the chip. So these three things are very important whenever you are starting any domain. Not only this domain, any domains you are starting in the chip manufacturing process, you need to know this, what is it, why we need it, and how do we do this. Okay, by keeping this agenda, let's begin the video. So what is verification? Verification is the process where we will check the functionality of the design Verification is the process of checking whether chip design works correctly before manufacturing. Okay, it is an exact process where we are checking all the functionalities have been working correctly in the chip. Okay, so you might be knowing that what is the difference between testing and verification. Testing comes post silicon process, verification comes pre silicon process. So we'll first check before going to fabrication, we'll check whether all the features have been supported by the design or not. Okay, so we understood what is verification. Now let's understand what is the need of it. So need of verification. So let's take a one real-time example where if we purchase any electronic gadgets or any electric vehicle, we need to if any in a very few days it got into fire, or the phone might get hanged. So it is all happening because of bugs which are there in a chip. Okay, so after we getting to know that after manufacturing, if that bug is present, if we are getting to know, means it is very difficult to resolve that bug, because after manufacturing the device, if we are going to resolve the bugs in the chip, it is a very complex process, it is very time consuming, and it is expensive also. So to avoid that, we are, as a verification engineer, we are performing all this flow before fabrication of the chip. That is why this verification is the very crucial step in the chip manufacturing process. So now we understood what is verification and what is the need in the chip manufacturing process. So let's begin the verification flow. So it is a complete verification flow from RTL code to reliable silicon. Okay, so first thing, RTL design. What is meant by RTL design is a register transfer level, where in this code we will be getting the functionality of the design. Okay, what are the features supported by, and what, like all the requirements needed for the design, everything will be there in the design. Okay, now we have RTL design. Now what, as a verification engineer, what we have to do? First thing, we have to analyze the specification. As a verification engineer, why we have to know the specification? Just we are checking, right? So it is a biggest doubt. But if we are verifying something, we need to know that what are all it is supported by. If we are verifying design, we have to understand what are all the features it is supported by, no? And what and all we can verify. That is the main thing. Okay, we analyze the spec, we have gone through everything done. The next thing is create test bench. So now we have to do our next important job, that is creating test bench. What is test bench here? Test bench is an environment. Through this environment only we are generating the input or a stimulus. Okay, so once we generated the input, we will start creating the test cases. So how test bench looks, that I will be explaining in the further slides. Okay, as of now it is an environment, through that we are creating the input. How we are going to write this environment? By using the UVM and SV, so that when we start exactly the training, that time we will be understanding what these languages are. Okay, so now as of now test bench is an environment to create the input, to generate the input. And then next, generating the test cases. What is meant by test cases? In the real time project process, whenever we are starting verification, we need to plan the, like we have to create the test plan. What is it means? In that we will be writing the feature supported by the design, and why we need to verify that feature, very detailed description. And also we have to write how we are going to do that, whether we are going to verify with the help of assertion, coverage or scoreboard, that we have to mention. We will be having one idea on how we can perform that. After that it is pass or failed, and why it is passed or failed. That is, it is an a brief overview of the test plan. Okay, in this we are going to create all the test cases, means what are the features supported by the RTL and how we are going to verify it. Okay, so now once it is done, we are going to for example, I have created one reset test case. Okay, so that reset test case I need to run it. So run the simulation. Like my RTL is supporting proper reset. Whenever reset goes low, whether all the signals are getting generated, like it is like how we can it is generating all the values or not. Whenever reset is high, all the signals has to go low. Okay, it is performing properly or not, I need to check. That is the main first foremost thing I need to check. Clock is generating and reset is working properly or not. That test case I have created and I have to run the simulations. In the simulation we have 3 steps. One is compilation, another one is elaboration, and the last one is simulation. Compilation means we are going to check whether my code is syntax all the syntax error free, like I don't have any errors in my code. That will be comes in the compilation. Next one is elaboration. In the elaboration we will check whether all the components have been connected properly or not. Okay, and I have to print the hierarchy, like topology I will print it. This is what happen in the elaboration. And the last one is simulation. We are going to like print the output for that reset test case. This is the 3 steps in the simulation, 3 phases in the simulation. So after running simulation, the main thing, debug the failures. If there are any bugs in the test case, like the bugs might come from RTL also and the test bench also. Like RTL, if we found any bugs in the test bench, we have to analyze whether whatever we are giving input, in that any errors are there, or what input we are giving for that RTL is supporting or not. This and all we have to analyze properly, and also we have to analyze with the help of waveform also. Okay, so everything we have to analyze from TB side. After that, if any errors, if any bugs from the RTL side, that also we need to check. If any bugs we found in RTL, we have to report to RTL engineers. They will come up with the updated RTL, and then we can proceed it further. If there are no any errors in the test bench, we have to go to RTL engineers. This feature I am going to verify it it is mentioned in the specification, but if I am giving any input, it is not supporting. It is a very simple way of approaching an RTL engineer. Okay, if we found any RTL bugs. Next, after that, once we debug the failures, after fixing bugs, we have to run the test case. Once we have completed with our running individual test case, now we have to go to the regression testing. What is meant by regression? Regression means I am checking my RTL with the help of multiple test cases. Multiple scenarios I am running together. That is, we call it as a regression testing. So, once I am completed with my regression, I will be getting the regression report, whereas how many, for example, in my environment, I have some 20 test cases. Actually, in real-time complex environment, there will be thousands test cases will be there. I am taking here simple example where I have 20 test cases. In the 20 test case, how many have been passed, how many have been failed, everything we have to check. How we have to debug those regression failures? First, we have to take that particular test case with the seed have been whatever we have given. After that, we have to run the single test case, why it is failing. We have to debug with the help of single approach, and then we have to analyze the waveform, and then we have to check the driver logic, it is driving properly, it is after that we have to go to this monitor, it is sampling properly from the DUT. All these steps have been taken properly in the regression debugging. Okay, this is what after every test case have been passed in the regression, we have to go to the coverage. As a verification engineer, we are concluding that this particular test case, this particular RTL verification has been completed by using the coverage closure. Coverage is an tool metric where we can analyze how much of code has been verified properly. We have two types of coverage. One is functional coverage, another one is code coverage. Functional coverage means like how much the functionalities have been verified. Code coverage means how many number of RTL lines have been executed. In that code coverage also we have branch coverage, we have FSM coverage, we have toggle coverage. In that we will check all the states have been transition properly or not, whether all the signals have been toggled properly or not. All these things we will be checking in the coverage. Okay, once we get the expected coverage percentage, we will be giving closure. Okay, this is what the entire complete verification flow. How it is important? In this flow, we will be finding the bugs, we will be resolving that, so it will reduce the cost and costly silicon bugs also, and it will ensure the quality of the chip, and we will get the customers trust also, and we will customers also will get confidence on the products. Okay, it is how the verification will play a major role in the chip manufacturing process. Okay, the next we'll see the test bench architecture. So it is an environment where we are going to develop all these components, whatever we are seeing right here, agent, sequence, environment, test, all these are components. This DUT, design under test, that RTL what we are going to verify it. Okay, so now the test will start from the hierarchical level. How we are going to start the test bench, to develop the test bench? We will start it from the test bench top. Okay, so in this test bench top, we are going to connect the signals from DUT and the TV, like whatever we are going to give the inputs. No, first we have to connect the signals. Once the connection of signals have been done, we are going to create the environment. Okay, so inside environment I will be having my test. So inside test I'll be starting my sequence. In the sequence we are going to give the input. We are going the stimulus, we are going to start it from the sequence itself. That I am going to start in the test. So after that I am going to create my agent. There are two types of agent. One is active agent, another one is passive agent. With the help of active agent, we are going to drive the input to the DUT. Passive agent, we are going to get the response from the DUT. In the passive agent, there is no presence of sequencer and driver, because only monitor is going to sample the output from the DUT. The driver and sequencer, there is no need of it. Okay, but active agent, all the three components should be present. Okay, this is what the importance of the agent. So inside agent, I will be having sequencer, driver and monitor. So from the sequence, I am going to start the generating the input, right? So the how the sequence is going to send it to the DUT. So there is a driver sequencer handshaking mechanism will be happen. So with the help of this driver sequencer handshaking mechanism, we'll get the input from the sequence, and that driver is going to send it to the DUT through the virtual interface. Why we are using virtual interface? Because in the SV we are going to use the OOPS concepts. So whereas class is the dynamic in nature, okay, but interface is the static. So to make it connection between both, we are using this virtual interface is pointing to the actual interface. With the help of this interface, we are going to send the input to the DUT. Okay, so interface, what it is a bundle of signals where we will use to connect between the test bench and the DUT. That is why through the interface only driver is going to send the input to the DUT. So once the DUT has received the input, it is going to generate the output. That output will be monitored by the monitor. Okay, once the output has been collected in the monitor, sampled in the monitor, we are going to send it to the scoreboard. What is scoreboard here? In the scoreboard, we are going to compare actual data and the expected data. Okay, so what is meant by expected data? Whatever input we are going to give it to the DUT, that is expected data. What is actual data? Whatever output we are going to get from the DUT, that is actual data. Both the data we are going to compare in the scoreboard. Once the scoreboard comparison has been completed, we are going to sample the data in the monitor to get the coverage report. That is why here from the monitor itself we are giving the connection to the functional coverage. Okay, this is how we are going to, once the expected coverage coverage percentage has been got, then we are giving the closures. Okay, this is how the test bench architecture looks. So now we'll understand one simple like how the real time, how we can run the test case in the project, and how the regression run looks. I have very simple environment. I'll be explaining with the help of that. So I have saved my project in the desktop. So I am giving CD desktop. Okay. So CD means change directory. So as we can see here, TVL, the verification lab. So in this directory, I have my project APB3. Okay. So in this I have, you can see I have my RTL, I have TB, and I have coverage, logs, all these things will be stored in that my project directory. So now make help. If I give make help, I will be getting all the commands whatever I am using now. Okay. So now you can see here list tests. Like first one is make help will show like what are all the commands I can use, and list test what are all the test case I have in my project. Here you can see make list test. If I give, it is showing all the tests have been present here. APB3 smoke test, error test. Okay, all the things I will be getting. Make list tests. See here, available APB3 test, smoke test, write readback test, wait state test, error test, back-to-back test, bit bash test, status polling test, and random test. These are all the tests present in my environment. Okay, and next one is compile. As I already explained, compilation, with the help of compilation, we will get to know any syntax error present in my code or not. That we will be getting to know with the help of compile command. Next one is run. Whenever we are running one single test, we will be giving this command make run test equals to test name and seed. What is the use of seed here? If we are creating random input, in that random input I want to see the output in a specific input. So that time with the help of this seed we will be identifying that specific input, and we are giving the input in that way. So in that case we will use the seed. Next one is regress. Regress means, as the flow I have explained, multiple scenario we are running at a time. Regress means if I am having 8 tests, consider I am having 8 tests. So in that 8 tests I want to run the 4 tests only. So I have to give regress command that time. Regress all means all the test case I am running together. Next, regress report. Regress report means like whatever the tests have been passed, failed, all the status I will be getting to know. This merging when we will use, when we want to check the coverage, that time we have to merge all the test case and we have to get the coverage report. After that we are like coverage, co-mode, waveform with the help of like if we want to analyze with the help of waveform, that time we will give the GUI mode, and open co text, open co HTML, this and all to see the coverage report. Clean and clean all, like if we have old simulation logs and all, to remove that we will be using clean and clean all commands. This is a brief overview of commands whatever we are going to use. Now let's see how to run the simple test. Make run test APB3 smoke test seed 1. Since it is a very simple environment, the run will complete very soon. And in the log we can analyze, here you can see here UVM info means what are all the displays we have given. So here you can see APB write address is this much, data, R data, slave error, wait, how much time it is waiting, all the things I can analyze here. You can see the path also here, UVM test top environment agent driver. Okay, and also here you can see UVM info, warning error, like fatal UVM fatal. If any fatal errors are there, it won't the simulation itself won't continue. Okay, it will stop the simulation. Errors, simulation will continue, but will the how many errors are there will be observing in the logs. Warnings, it won't affect the simulation. And infos, what are all the displays we have given, all these things are will be observing here. So and here with the help of log also, there is separate log has been created for this test case. In that log also we can analyze our observation. Okay, for that particular test case. This is how we will run the single test case. Now we'll see regression also. So make regress all. Since there are only 8 test cases, the regression will complete very soon. But in complex environment, the regression might go 2 days, 3 days, week. Okay, it depends on how many test cases we have, how much complex the environment is. Okay, so now the regression has been completed. So now if I go to logs, here you can see the regression report. Cat regression report text. See, you can see here how many the test case name, how many total test cases are there, how many passed, how many failed, and any UVM errors, and what is the status of the test case, particular test case, and the seed number, past transactions. Everything will be getting to know with the help of regression report. This is how the simple regression report looks. Next we'll see coverage. So now make merge. So now merging of all the test case have been completed. Now we have to see the coverage. Make help, make open co HTML. You can see here how the coverage report looks. The percentage of the coverage and the statement coverage, branches, FEC conditions, toggles, assertions, both all the things we can observe here, and how many passed, how many warning, error, fatal, all the things will be observing here. This is how the coverage report looks. Okay, it is a simple overview. As a time constraint, I will be explaining how the coverage report looks. This is how in the real time, how we will analyze the coverage, how we will check the regression report, how we will run the single test case. It is a brief overview of real time project implementation. Okay, so now let's go back to our webinar. So here, so now we are at end of our session. So here the verification lab. So if you join this institute, what are all you will be learning? You will be learning SV, you will be learning UVM, QuestaSim, Makefile, Linux, Vim, Git, all the things you will be learning, and also hands-on project. We will be training you many projects in SV, major projects such as asynchronous FIFO and APB, and we will be assisting you how to build the resume, how like regarding career support, and anything, any real-time updates, job updates, all the things will be posted timely. Updates we will be posting in our WhatsApp community. Okay, if you join there, all the related, when the classes will start, all the things we will be getting to know, and the course duration will be 4 to 5 months. In this 4 to 5 months, you will be analyzing what are all the things there in this particular DV and RTL domains. Okay, when you enter into the real time work, you will not be feeling any stuck. Okay, if they assign this work, how I have to do. So that much very practical learning you will be understanding in this training period. Okay, so now here also you can see, as in the RTL what are all the things you will be going to learn, and in the DV what are all the things you will be learning. All the things will be updating in our community. Please join our community and subscribe this channel. You will be getting to know and what are all the latest updates related to institute. And also there is no restriction that you have to join the course immediately. You can take the, we will be giving the free classes too. You can attend the free classes. After that also you can decide whether to join or not. Fee structure, when the course is going to start, all the updates will be given in the community. Please join the community for the updates about the classes. Thank you for watching this video.